Hey everyone, and welcome to CS Course Companion, your go-to channel for breaking down computer science concepts. Today, we are diving into one of the biggest, most important technologies out there, artificial intelligence. And we're going to start with a moment that literally shocked the entire world. Picture this. It's March 2016 in Seoul, South Korea. The world's attention is glued to a game. But this isn't just any game. This is Go, an ancient board game that is so strategically deep, so complex, it makes chess look like checkers. On one side of the board, you've got Lisa Doll, a legend, one of the greatest Go players of all time. And on the other side, a machine, an AI named AlphaGo. The final score was 4-1, a decisive, almost unbelievable victory for the machine. And this wasn't just about winning a game. No, this was a massive signal to the world, a huge leap forward for artificial intelligence that really got everyone's attention. So that leads us to the big question, right? How on earth did a machine manage to master a game that has more possible moves than there are atoms in the known universe? Seriously. To figure that out, we're going to trace the story of AI right from its birth. We'll check out some of the very first thinking programs. We'll uncover the secret to how AlphaGo actually learned to win. And then we'll lay out the 4 major areas of AI that you'll definitely see in your classes. To really understand how we got to something as incredible as AlphaGo, we need to go back in time, like way back to where the idea even came from. So this timeline here shows some of those key moments. Now, the first electronic computers back in the 1940s gave us the hardware, the physical machines. But the actual idea of AI as a field of study, that didn't really catch fire until one specific event in 1956. And that event was the Dartmouth Summer Research Project. A computer scientist named John McCarthy, who we now call the father of AI, got all the top minds in the country together for this huge month-long brainstorming session. And it was right there that he came up with the name we all use today, artificial intelligence. Of course, the concept of intelligent machines was already kind of floating around. About 6 years before that Dartmouth conference, the absolute genius, Alan Turing, published this groundbreaking paper asking a really profound question. Can machines think? That single question pretty much set the stage for everything that came after. So the idea was out there, the field had a name. What did the very first thinking machines actually do? Well, funny enough, researchers kind of split off into 2 very different directions. And you can really see this split in the 1960s with 2 super famous early programs. On one side, you had a program called ELIZA, which was all about language and conversation. And on the other side, you had Shaky the Robot, which was all about moving around and interacting with the real physical world. ELIZA, which was built at MIT in '66, was basically one of the world's first chatbots. You type back and forth with it on a machine like this. And its trick was actually pretty simple. It would just rephrase your own statements back to you as questions. But the effect was, well, kind of powerful. A lot of people felt like the machine genuinely understood them. Meanwhile, while Eliza was busy talking, Shaky the robot was out there doing things. It was the first mobile robot that could actually reason about what it was doing. It could look around a room, navigate around obstacles, and plan out a series of actions to solve a problem. And get this, its basic search algorithm is a direct ancestor of the technology that powers stuff like Google Maps on your phone today. Pretty wild, right? So how did we get from a simple chatbot and a robot bumping around a room to an AI that could beat a Go grandmaster? Well, that massive jump required a completely new way for machines to learn. See, AlphaGo didn't win by just crunching numbers faster. It won because it learned. First, its creators fed it a database of 150,000 games played by human experts. It used that data to find patterns and predict human moves. But here's the brilliant part. After that, it started playing millions of games against itself, getting a tiny bit smarter with every single game. It basically became its own teacher until it surpassed all of its human creators. So it's really important to remember that AlphaGo is just one amazing example of what AI can do. As a computer science student, you've got to understand the whole landscape of the field. Generally speaking, any AI course you take is going to break down into these 4 big pillars. First, you've got representation and search. That's all about how we frame problems so a computer can even begin to solve them. Second is capturing intelligence, which is about building expert systems that try to copy human decision-making. Third is machine learning. That's the powerhouse behind AlphaGo that learns from data.
And finally, you have advanced topics like natural language processing, which is basically the modern, super advanced version of ELIZA that lets us talk to our phones and smart speakers.
Let's just zoom in on machine learning for a second. There's this super cool subfield called nature-inspired computing. The core idea is that, hey, nature has been solving really complex problems for millions of years, right? So we can actually design algorithms that are inspired by things like how ants find food or even the structure of a bird's nest. And we can use those ideas to solve computer problems. Like in this example, teaching an AI to perfectly separate the different parts of a flamingo in a picture. It's all about looking to the natural world for answers. But even with all these incredible advances, from beating world champions to getting inspiration from nature, AI still has a really hard time with things that are just ridiculously simple for you and me. And this brings us to a famous paradox in the field, sometimes called the first law of AI. The hard problems are easy, and the easy problems are hard. What does that mean? Well, a machine can master the mind-boggling complexity of Go, but it might struggle to understand a simple children's story, or even just pick up a glass of water without crushing it. So what is the biggest easy problem that AI has, for the most part, totally failed to solve? It's one thing: common sense. You know, that giant library of unspoken rules and intuitive knowledge we all have about how the world works. Simple stuff like water is wet or you can't be in two places at the same time. And that leaves us with the big open question for the entire future of AI. We've seen how far it's come, from those first simple chatbots to world champion game AIs. But the next great leap might be the hardest one yet. Can we ever build a machine that truly understands the world with the simple, intuitive common sense of a child? And that's all the time we have for today. If this helped you get a better handle on the fundamentals of AI, make sure you subscribe to CS Course Companion for more explainers designed to help you with your coursework. And hey, let us know in the comments what computer science topic you want us to break down next. Thanks so much for watching.